This question asked in GATE 2023 of electrical. This is from control system subjects and from block diagram algebra topic. The question is, for the block diagram shown in the figure, the transfer function ys by rs is. So this is what ys, this is rs, we are supposed to find this ratio. So student, directly we can think of the Mason-Gain formula, okay. It's although it looks like a block diagram, in your mind you can easily think how the signal flow graph of this will look like. So that how many paths are there, forward paths are there. So P1, if I say, so this is one path. So the gain is 2 into 1 by s is 2 by s. You have other forward path which is this one. So which is the gain is 3. Do you have anything else? We don't have anything else. We cannot go this way because we cannot travel in the reverse direction of the arrow, right? We cannot go this way. So there are only two paths. And how many loops are there? So loop, there is only one loop. I can see this one. So what is the gain of this loop? This is your 1 by s. But whether is it a loop? It's not a loop because I cannot go this way then, right? So using Mason-Gain formula, your y of s divided by r of s is equals to P1 gain, that is 2 by s, and there is no non-touching loop, so it is 1 minus 0 plus then P2 which is 3. Again there are no non-touching loop, it is 1 minus 0 divided by 1 minus loop gain. What is the loop gain? Loop gain is 1 by s, and it's natural, it's a positive feedback system, that's why we are getting this negative sign, okay. So 1 minus 1 by s. So if you simplify this, so this happens to be 2 by s plus 3 divided by 1 minus 1 by s. Let us multiply ss in both numerator and denominator. You get it is 3s plus 2, and then you get this is s minus 1. So 3s plus 2 divided by s minus 1, this is what the transfer function is. So if you check it out, 3s plus 2 by s minus 1 is given option B. So B is the right answer for this problem. Okay. So simple and straightforward problem. Answer is option B. This question asked in GATE 2023 of electrical. This is from control system subjects and from Nyquist plot topic. The question is, in the Nyquist plot of the open loop transfer function GSHS corresponds to the feedback loop shown in the figure, the infinite semicircular arc of Nyquist contour in S-plane is mapped into a point at. So here the point we should note is infinite semicircular arc. Okay, what is the meaning of it? So when we select that Nyquist contour, which is the entire right half of S-plane, so for this infinite semicircular arc, the value of S is infinite. So in simple language, they are asking, so if S value is infinite, then what is the value of this transfer function? That's what they're asking. You see here, the infinite semicircular arc of Nyquist contour in S-plane is mapped into a point at what? So they're asking, what is the value of the transfer function when S is infinite? So the answer would be limit s tends to infinite. So if I take s common, it is 3 plus 5 by s, and if I take s common, it is 1 minus 1 by s. So s cancel out. So if you substitute s equals infinite, it is 3 plus 0 divided by 1 minus 0. Answer is 3. So straight away answer is option C for this, which is 3. This question asked in GATE 2023 of electrical. This is from control system subjects, and it is based on basics of control system with a little bit idea of PI controller. The question is, consider a unity gain negative feedback system consisting of plant GS given below and a proportional integral controller. Let the proportional gain and integral gain be 3 and 1 respectively. For a unit step reference input, the final values of the controller output and the plant output respectively are. So based on the given data, we can have the transfer function, the block diagram representation. So for the PI controller, you know students, so if I denote the transfer function of PI controller is QS. So it is in general given by Kp plus Ki by S. Kp is the proportional gain, Ki is the integral gain. So Kp is 3, so it is given 3, and Ki is 1, 3 plus 1 by S. So if you take LCM S, so it is 3s plus 1. So the block diagram is like this. So this is your plus and this is your minus. So here you have your Q of S, the PI controller, and then it is G of S. This is how the actual control system is, right? So first the error detector output signal is given to the controller, and it acts on the error signal and it generates some command signal to plant. So this is the standard model. So let us name this is your W of S. Let us name this is your let's say R of S, and this is your C of S. So what they're asking is, if you see the questions for unit step reference input. So if the input is unit step, so C of S is 1 by S in S domain, or it is basically UT in time domain. So if the input is unit step, what is the final value of controller output and plant output? So controller output is WS, plant output is R of S. Final value, that means we are supposed to find what is W of infinite and what is your R of infinite. For what? For input, your CT is equals to UT. Okay, if the input is CT equal to UT, then what is this W infinite, R of infinite? So if I ask you what is WS by C of S, so what is the idea is, first I'll find what is WS by C of S. Then by substituting C of S, I'll get WS. Then by using final value theorem, I can get what is the final value of this. Similarly, to get final value of this R of S, I'll first find what is R of S by C of S. Then by substituting CS equals to 1 by S, I'll get what is R of S. Again, using final value theorem, I can get what is R of infinite. So that's why I'll first obtain the transfer function WS by C of S, and then I'll obtain R of S by C of S, and then we'll proceed. So WS by C of S, so how much this will be? This is QS whole divided by 1 plus QS multiplied by G of S. QS divided by 1 plus QS GS. So what is QS? QS is 3S plus 1 by S and 1 plus QS GS. So 3S plus 1 by S multiplied by G of S, which is 1 by S minus 1. So now let us multiply S into S minus 1 in both numerator and denominator. If I do that, S into S minus S will be cancelled out. So it will be S minus 1 into 3S plus 1. And this is again S into S minus 1 plus it is 3S plus 1. So if you simplify this, so this is 3S plus S minus 3 minus 1. 1 second. This is 3S, right? Sorry. So this is basically 3S plus 1, right? So if so, then if you simplify this, so this happens to be 3S square plus S minus 3S minus 1 whole divided by, this is S square minus S plus 3S plus 1. So now if you simplify this, so this happens to be 3S square, S minus 3S is minus 2S minus 1 whole divided by S square plus 2S plus 1. So this is your WS divided by C of S. So what is WS if I ask you? So it is 3S square minus 2S minus 1 divided by S square plus 2S plus 1 into C of S. But we know C of S is 1 by S, because you see here C of S is 1 by S. Right? C of S is 1 by S. So in place of C of S, so let me substitute 1 of S. So now I am supposed to find what is final value of this, the controller output, that is W of infinite. What is the corresponding time domain signal of this one at t equals to infinite? So we can use the final value theorem. W of infinite is equals to limit S tends to 0, S into W of S. So this is equivalent to limit S tends to 0, S into WS. If you see, it is 3S square minus 2S minus 1 divided by S square plus 2S plus 1 whole multiplied by 1 by S. This S and this S cancel out. If you substitute S equal to 0, so this is 0, this is 0, this is 0 and this is 0. So you are left with minus 1 by 1. So the answer is minus 1. So this W of infinite which is asked, so this is minus 1. In other words, they are asking final value of controller output and plant output. So controller output, this answer is minus 1. Now we are supposed to find what is the plant output. So if I check the options, option A is wrong. So option B is also wrong. C is also wrong. D has to be the right answer, because first has to be minus 1 and then 1. So you can say option D is the correct one. But anyway, let us see how the plant output is coming as 1 as per option D. So the plant output, if you see, so that is R of S divided by C of S. So this is given by Q of S into G of S divided by 1 plus G of S into Q of S. If I substitute all these data, Q of S is 3S plus 1 by S, G of S is 1 by S minus 1 whole divided by 1 plus, again the same thing, 3S plus 1 by S into 1 by S minus 1. So let us multiply S into S minus 1 in both numerator and denominator. If I do that, you get 3S plus 1 and here you get S into S minus 1 and then it is simply 3S plus 1. Now again, if you simplify this, this is 3S plus 1, this is S square minus S plus 3S plus 1. So this happens to be 3S plus 1 whole divided by S square plus 2S plus 1. This is your what? R of S. So R of S by C of S. So what is R of S if I ask you? If you multiply C of S that side, so C of S is 1 by S. So it is 3S plus 1 divided by S square plus 2S plus 1 whole multiplied by 1 by S. So now you need R of infinite. Using Fanouville theorem, it is limit S tends to 0, S into R of S. So this is equivalent to limit S tends to 0, S multiplied by this entire thing, 3S plus 1 divided by S square plus 2S plus 1 and this is 1 by S. So this has cancelled out. If you substitute S equal to 0, this term is 0, this term is 0, this term is 0. So you are left with 1 by 1. The answer is 1. So you see, this is the plant output. The final value of plant output is coming as 1. So final value of control output is minus 1 and final value of plant output is 1. So the answer is minus 1 and 1, which is of course given in option D. So D is the right answer for this problem. This is not a tough problem, student, but yes, slightly lengthy problem. So because I'm explaining every step, I'm taking around 8-9 minutes of time. But if you solve in proper flow, it should not be much beyond 5 minutes of time. So answer is option D. This question is asked in GATE 2023 of electrical. This is from control system subjects and from Bode plot topic. The question is, the magnitude and phase plots of an LTA systems are shown in figure. The transfer function of the system is. So this is the magnitude plot, this is the phase plot. So what transfer function this represents among this they're asking. So student, you see that the magnitude plot is constant for all frequency and the phase plot is linearly decreasing for all frequency. So it is definitely the transfer function will have the format k into e raised to power minus s tau, because in this case if I take the magnitude, okay, so this is k for all frequency, and if I ask you what is the phase of this, so the phase of this is simply minus omega tau for all frequency. So definitely this has to be the format k into e raised to power minus s tau. So in that way, so option B is anyway eliminated. So answer could be A, C or D. So you have to find the value of A. We have to find the value of this k and we have to find the value of this tau. So how do you get k? K is the magnitude, so you have to get from the magnitude plot, and this tau, time constant of the transportation lag factor, you will be getting from this phase plot. So how do you get it? So if you see this, so if I ask you what is the magnitude of this in the dB format, so it is GS is k into e raised to power minus s tau, we are telling, right? So GS magnitude is k. So k, but in the log scale, because plot is in log scale, so it is 20 log k. So this is 20 log k. So I can tell that this 20 log k is equals to 8. At what frequency? At all frequency. So no issues. So log k is equals to 8 by 20, or k is equals to 10 to the power 8 by 20. So if you simplify this using a calci, it is coming as 2.51. So this is 2.51 into e raised to power, minus, and here it will be s, and you have to find the tau factor. So from this, option C is also wrong. So answer could be either A or it is either D. So now what about the phase? So phase plot, if you check it out, so minus omega tau is the phase of this transfer function, right? So if I ask you what is the phase of it, it is minus omega tau. right? So the phase is contributed by this exponential factor. The magnitude of the exponential factor is 1 always. So the phase of this is minus omega tau. So this minus omega tau, if you check it out, so this is basically how much? This is basically 60 degree or minus pi by 3 in radian units. At what frequency? You see, this is 60 degree, minus 60 degree at 1. Yes or no? This is minus 60 degree at 1. And minus 60 degree equivalent to pi by 3. So I can tell that. So here your omega tau equals to minus pi by 3 at what frequency? So this is minus pi by 3 at what frequency? At omega equals to 1. So minus omega tau equals to pi by 3 at omega equals to 1. So this implies your tau is equals to pi by 3. So pi by 3, if you check it out, this is coming as 1.047. So tau is equals to 1.047. Because the total phase is minus omega tau and this total phase is minus pi by 3 at a particular frequency omega equals to 1. So by simplifying this, tau is equals to pi by 3, which is 1.047. So if you substitute here tau equals to 1.047, so this is how it will look like. So the transfer function is 2.51 into e raised to power minus of 1.04s, which is given in option D. So A is also false. Just simple problem, students. So because I'm explaining every step, I have taken on 5 minutes of time. But if you solve in a proper flow, it is not more than 2 minutes of time. So magnitude is constant, phase is linear decreasing, means it is k into e raised to power minus s tau model transfer function. So by taking the magnitude plot directly, you can get the value of k, which is coming 2.51. And by selecting this phase at a frequency omega equals to 1, which is minus pi by 3, we are getting the value of tau is 1.047. And by substituting k and tau value here, this is what the resulting transfer function. This question is asked in GATE 2023 of electrical. This is from control system subjects and from compensator topic. The question is, consider a lead compensator of the form Ks. The frequency at which this compensator produces maximum phase lead is 4 radian per second. At this frequency, the gain amplification provided by the controller, assuming asymptotic Bode magnitude plot of Ks, is 6 dB. The value of alpha beta respectively are. So students, so let me show you the Bode plot of a lead compensator, right? We are dealing with lead compensator. So the Bode plot of lead compensator, it looks something like this. Like this. So this is what is your alpha, and this is what your alpha beta, and somewhere here we have this omega m. Omega m is that frequency corresponds to which maximum phase lead happens. So if you see, they are saying that the frequency at which this compensator produces maximum phase lead is 4 radian per second. So at this frequency, maximum phase lead happens, and they are saying that at this frequency, at omega m, the gain amplification provided by the controller, assuming asymptotic Bode magnitude plot of Ks, is 6 dB. That means at this frequency, this gain is basically 6 dB. So this is your 6 dB. Okay. So based on this data, we are supposed to find what is the value of alpha, what is the value of beta. And omega m is known to us. So here they are saying that this omega m is 4 radian per second. Now student, this omega m, this happens to be the geometric mean of two kernel frequency. So the kernel frequency are alpha and alpha beta. So omega m happens to be alpha into alpha beta square root of it, which is square root of alpha square beta, which is alpha root beta. So alpha root beta, so this value is basically 4 radian per second. So they are saying omega m is this one, and omega m in terms of kernel frequency is given by these relations. So this is one equation we got. Alpha square root of beta is equals to 4 radian per second. Now next thing is that you should know that, so this magnitude is given 6 dB at what frequency? At omega m frequency. And what is the slope of this line? The slope of this line is 20 dB per decade, right? This is your log omega axis. This is 20 dB per decade. So, and I know the amplitude of this line at a certain frequency omega m. So you can write that slope equation here, and from there we'll get one equation. See, because you have only one equation now in terms of alpha beta. To get alpha beta both value, we need two equation, right? One equation we have. Let us try to get the second equation by writing the slope equation of this one. So because the slope is 20 dB per decade, so slope is 20 is equals to, so my point is this point and this point. I mean, I'll be doing that y2 minus y1 by x2 minus x1. So y2 is 6, y1 is 0, x2 is log, it's log axis, log omega m, and this is log alpha. Is that no? So I can write that 20 is equals to, so 6 dB minus 0 dB, 6 minus 0 divided by log of omega m. Omega m is directly I'm writing this alpha square root of beta, alpha square root of beta minus log of alpha. This implies log alpha root beta minus log alpha. This happens to be 6 by 20. This happens to be 6 by 20. So log A minus log B is log A by B. So log alpha root beta divided by alpha is equals to 6 by 20, or this is basically 3 by 10, which is basically 0.3. So alpha cancel out. So square root of beta is equals to 10 to the power 0.3. If you check it out, this is coming as approximately 2. So if square root of beta is equals to 2, so naturally your beta is equals to 2 square, which is 4. So beta is equals to 4. So we can substitute this beta value in this equation, which will give me the alpha value. So alpha is equals to 4 by square root of beta. So square root of beta is 2. So 4 by 2 is equals to 2. So we got the value of alpha is 2 and beta is 4. So alpha 2, beta 4, if you check it out. So this is being satisfied by option B. So B is the right answer. So this is again, student, a very general model questions. So some data regarding the compensator was given, like the frequency at which maximum phase delay happens and the amplitude of signal at that frequency. So using the geometric mean property, we got one equation in terms of alpha beta, and using the slope equation of this amplitude, we got one more equation in terms of alpha beta. So by solving this equation and this equation, we got the value of alpha 2 and beta is 4. So if you check it out, answer is option B for this. This question is asked in GATE 2023 of electrical. This is from control system subjects and from state space analysis and frequency response concept. The question is, consider the state space description of an LTI system with matrices A, B, C, D. For the input sine omega t for omega greater than 0, the value of omega for which the steady state output of the system will be 0 is how much? So this is a system. Generally, systems are described by transfer function. But here the transfer function is not given, rather its state description is given. So for this system, let's say the transfer function is Ts. So the input is sine omega t. So what is the frequency we should select so that the output will be 0? So this kind of problem we have already seen, like in multiple time in GATE it has been asked, like the input is sinusoid, then what is the corresponding output? So that model of question, the only thing is the transfer function is not given, but the data which is given, from there we need to find the transfer function. So it's a 2 cross 2 matrix, students, the A matrix is, and we have some shortcut for this. I believe all of you know this. Anyway, let me write the shortcut. So if A happens to be 0, 1 minus A naught minus A1, and B matrix happens to be 0 and K, and C matrix happens to be B naught B1, and D is anything, okay? So for such kind of cases, the transfer function Ts is given by K into B naught plus B1s divided by A naught plus A1s plus S square plus D. In fact, if you don't know this shortcut, you can make use of C into Si minus A inverse into B plus D. So this is the way. So in case if the transfer function, the data is in this model, you can make use of this. Because in most of the GATE exam, okay, most of the year paper, if you see the past papers, such models are being used frequently. So this is just a shorthand formula you can think of. So many times D happens to be 0, so this factor doesn't come. But in this case, the D matrix is not 0. D is 1. So we have to take care about that also. So let us find the transfer function. So transfer function, if you see here, so Ts is equals to, if you see K, so K is basically 1. So this is 1. B naught, so this is B naught. So B naught is basically 3. So 3 plus B1S. B1 is basically minus 2. So it is minus 2 into S divided by A naught. So minus A naught equals to minus 1. A naught equals to 1 plus A1. Minus A1 is equals to minus 2. A1 equals to 2. So you get 2S plus S square plus D. So D is basically 1. So if you simplify this, so this happens to be 3 minus 2S divided by S square plus 2S plus 1 plus 1. So now if you take the LCM, this is S square plus 2S plus 1. This is 3 minus 2S plus S square plus 2S plus 1. So now if you simplify this, so minus 2S plus 2S cancel out. So you get it is S square plus 4 divided by, this is coming as how much? S square plus 2S plus 1. So this is your T of S. So if you write this in the omega form, so you replace S by j omega, you get j omega whole square plus 4 divided by j omega whole square plus j2 omega plus 1. So this happens to be 4 minus omega square. This is 1 minus omega square plus j of 2 omega. Right? So this is what is the transfer function happening. And you know, the concept is, if you are expecting the output to be 0, so you want the magnitude of this transfer function at frequency omega, it should be equal to 0. So you have to find the magnitude of this. So you should equate that magnitude equal to 0. So that will give you the omega value, because if the magnitude is 0, so output will be definitely 0, because the output will be, so if the input is, let's say this is the system, if the input is, let's say sine omega t, and let's say this transfer function is T of S, and so if I ask you what is the output, so the output, let's say the input is, let's say A sine omega t plus phi, and the transfer function Ts, what is the output if I ask you? Then the output is A into T of j omega magnitudes, then sine, frequency will not change, omega t plus phi. Along with this, it will also contribute some phase angle of this transfer function. This is what will be the output. If the input is this quantity having this transfer function, this is what the output is. So if you are expecting output to be 0, and then definitely this factor has to be 0, because A is 1 in this case. So if you are expecting this to be 0, so you need this to be 0. So this is your T of j omega. So if I ask you what is the magnitude function T of j omega magnitudes, so it is 4 minus omega square divided by 1 minus omega square whole square plus 4 omega square. So you are expecting this to be 0. If you are expecting this to be 0, it means that the numerator of this function is 0. So that is 4 minus omega square equal to 0, or omega square equals to 4 and omega equals to 2 radian per second. Although it is minus 2, frequency cannot be negative. And in the question also they are telling that omega is greater than 0. So the value of the frequency is 2. So okay, so answer is 2 for this. This is, again, if you don't know this formula, this is a bit lengthy. Electrical paper itself is lengthy this year. So anyway, there is no, it's not a tough problem, but yes, you can say it's a lengthy problem if you don't know this shortcut. So first we have to get the transfer function, and then by finding the magnitude, so you have to find what condition it is 0. So numerator becoming 0, 4 minus omega square is 0. So omega equals to 2 radian per second. So the answer is 2 for this.